Thank you very much for having me. And tonight I will be speaking about privacy by design. I, Pham, am founder and CEO of Numina. We're a company based in Brooklyn, and we make a data utility for cities. So really what that means is we make a full stack censored enabled platform for cities to make their streets queryable. Basically, we measure everything going on in streets, and we provide that data both to urban planners and operational staff within the city, as well as to companies via an API. And obviously, because we're collecting data from the public right-of-way, privacy is very important, and it's been built into our mission and our culture from day one that we provide intelligence without surveillance. So with our sensors, this is just kind of a sample snippet, but we're really just collecting what is the object. So you see the class as examples: pedestrian, car, bus, truck, wheelchair, dog, bag of trash, could kind of be anything. And then we're showing where it is in the street. So this box is essentially, these are related to XY coordinates in the image, and a timestamp. And from there, we can do some really exciting things. So we can show what is in the street, where is it in the street, how it moves in the street. So those are things like speeds, dwell times, interactions. And we can do all of this without ever collecting personally identifiable information. And without any PII, with that very small data that we collected at the edge on our sensor, we can start to show some really cool things, like how everything moves on the Pedestrian Mall, Fulton Pedestrian Mall in downtown Brooklyn, which is this particular scene. And our sensor is obviously capable of picking up a lot of data. Any given sensor there is measuring about 50,000 pedestrians a day. And this is all at the edge. So we process the imagery our sensor is taking in on board the device. And then we get some really cool things. Like this is a plaza that we're measuring in a city called Nijmegen in the Netherlands. Obviously, green are pedestrians. It's kind of just a sea of activity. And then one day we noticed that the data had changed, and we didn't really know what had happened, but it turns out that it had snowed. And so these are some of the kind of fun visualizations we can do. But why this is really important generally is about bicycle and pedestrian safety. So just a very specific use case. This is a street in Jacksonville that we measured. Jacksonville has the highest pedestrian fatality rate of any major American city. And here we're looking at pedestrian tracks in the street. And this was useful to them because it's a very sprawled city. It's actually the largest city by land area in the States. And it was very easy for them to understand where they should actually be putting their mid-block crossings so that pedestrians would stop getting hit by cars. This is a solution that did not come easily for us. This is kind of a side note, but our sensor is completely purpose-built for streets. So our goal as a company is to measure the 45% of land area in cities that right now no one is really measuring. It's the space between buildings. And we do that with a sensor that mounts to light poles, has a battery backup, so when power is inconsistent, our sensor still runs consistently. We're processing all of the imagery. Our primary sensor is a camera, but in our device, we're processing all of the imagery there. And then we don't save or transmit the imagery. So we can send very small data packets over cell phone network. That's how they're connected. So we started with, this is actually kind of our first real street deployed prototype. We had soldered together 18 D-cell batteries every time we wanted to mount a prototype to a light pole, and that would get us a day of power. So that really sucked. But now we have sensors in downtown Brooklyn. We just launched our Gen 2 product there at the end of September. And we have 100% uptime over the last 100 days. We've measured over 480 million data points since the end of September, which really looks like about 45 million objects. And that is with actually only 4 sensors. And we are about to be in 12 cities, so I'll explain that further. What is exciting about this data is the sensor is not really the product, the data is the product. Because we don't have any PII tied to our data, it's very safe for us to share with companies. And so we are now in the process of making our API available to third-party companies. so that they can build applications, kind of like an if this, then that for streets. When traffic reaches a certain level, or when trash builds up to a certain level in the street, trigger some response. And these are not just vendors to the city itself, but mobility companies, real estate companies, insurance companies, lots of companies that are interested in what's going on in the public right-of-way. As I mentioned earlier, and the actual topic of this talk is that we are committed to providing intelligence without surveillance. So because we deploy in the public right-of-way, unlike with consumer products, the people that we are measuring never opt into our service. For that reason, it is of the utmost importance that we protect their privacy and don't infringe on their rights. Also, when my co-founder and I started the company in 2014, pretty much all the headlines were Snowden and Prism. So we thought immediately from the beginning, we know that computer vision is the solution for our problem, which was measuring all these things in streets accurately, and ideally with one sensor, a camera. But we don't want to have imagery for the government to subpoena from us if ever it came to that. And so that's why we decided on doing processing at the edge, and hardware was reaching a point where that was possible. And so we are completely privacy by design. So I'm going to walk through our process of how we protect citizen privacy. So first, we are minimizing all of the data by processing at the edge. We glean all of our data, again, what is the class of object, where is it in the street, and a timestamp. We do that on board the sensor, and then we don't have to save or transmit the imagery because we don't need it anymore. And we discard them every 30 seconds. Even with just that very minimal data, again, you can create these visualizations, and then in our dashboard, actually what most planners use as a feature is they're able to draw their own polygons and screen lines over the street and isolate counts to different areas and create their own triggers and notifications based on those areas of the street. So if you look at, let's say, really any of these intersections, with a traditional traffic sensor, you would probably need at least 12 sensors to measure accurately where and what and how many of everything there are, because most sensors are a tripwire style counter, a screen line counter. So it's a wire under the loop, it's a puck under the pavement, it's an inductive loop, wire under the pavement, or a puck under the pavement. Sometimes it's an infrared tripwire, but all you're getting is a binary, did an object cross my line or not? In our case, we're obviously showing the paths, and from that we can also get speeds, trajectories, proximities, and differentials between objects. And so all of that is with very little data, and we didn't feel that we needed to collect more for this to be valuable at an urban scale. The second thing that we do is we encrypt all of our data with TLS1 industry standard AES 256 encryption at transit, and then all of our devices have to have authorization. We rotate keys regularly. There's very little surface area for attack in our system. And then we do sample imagery. So if you know anything about computer vision, I guess I made an assumption that this audience might. Computer vision is a form of machine learning and AI. Generally, it works by exposing your algorithm to thousands of sample images or training sets. So if I want to train my algorithm to recognize pedestrians very well, I want to show it every kind of pedestrian from every angle, from every distance, doing every activity, thousands and probably millions of images. And that's why having a very purpose-built application is very helpful with computer vision. So we are the best at measuring people in streets because our training sets are all based on people in streets. What is important is that obviously if you're doing your processing at the edge, you need to be able to validate that. So we would like to assume we're 100% accurate, but we're not. And so we need sample images to understand how accurate are we. And if there is something wrong on board the sensor or it's a funky site, we can kind of fix it over time. So there are examples where, for example, we might have a site where a fountain is constantly being detected as a car. It doesn't really make any sense. We don't know why, but we can kind of hard mine that out to make it more accurately detect cars and not fountains. And so we do sample imagery off the sensors. We do actually transmit some imagery. We do it once per hour at a random time per hour, so it would be almost impossible to intentionally surveil anyone retroactively with that sample rate. And we can do that, at such a scale with sensors in the world that it's still a meaningful data set, and we can retrain our sensors with some of the information when we annotate those images. And when we annotate the images, we're always de-identifying the imagery automatically before any agent, human or software, sees it. So this is the kind of detection that our sensor does. But you can see that where it has detected a person or a bicycle or a vehicle, we actually apply a blur effect. Already our camera is only a 3 megapixel camera, so it's low res enough. Actually, in most city settings, you can't really see a person's face anyway. But the crazy thing about PII, personally identifiable information, is that it's always evolving. So you could have enough context clues about a person without being able to decipher their face and still maybe guess who they are. So we do what we can to remove PII before even our staff looks at an image to, let's say, annotate or correct a misdetection or an incorrect detection. And then lastly, we don't save imagery beyond 30 days. So we have a constant sort of influx of new training data, and we don't have a big store of data that could in any way be recalled and, again, used towards surveillance. So our mission is to empower cities with data to become more responsive. We do not think that that data has to have anyone's personally identifiable information, that cities can actually be more walkable, more bikeable, more responsive, more equitable, without needing to know any individual's identity. And so we're committed to that, and it's working. So we'll be live in at least 12 cities before April. It's looking like more. Most startups especially don't sell to local government. I imagine at this meetup you see a lot of maybe federal focused technology that is commercializing out of the DoD, let's say. But generally, cities are not considered early adopters of frontier tech. But we've sold cities in a sales cycle is 10 days. So if you make something they really need, they'll figure it out and they'll buy it. And our model is to align our incentives with the city where they're getting value out of this data, and so can other companies. We're a small team of 9 people, and we're based in Brooklyn. Oh, that advanced. We're hiring right now, so if you're interested in the problems that we're solving, everything from hardware to cloud to computer vision and anything on the biz dev side as well, please come and find me. Again, my name is Tara, and we also have a couple of our other engineers here, so thank you.
Thank you very much. Maybe talk a little bit to the business model.
Yeah, so first and foremost, we sell, usually about half our customers are municipalities. They buy the hardware for a one-time fee, and then they pay a subscription per sensor for the data, the dashboard, access to the API. In most of our contracts, we actually retain ownership of the data, or at least some commercial right to the data. Our sensor is anywhere from 5 to 20 times less expensive than other traffic sensors, and so the city sees it as a way that we're subsidizing the price to them. In the future, we would love to do more to actually build a marketplace for the city and rev share with them so that they're incentivized to kind of market our data for us, and so that we're aligned and it's a system that they're hooked into.
And traffic is the wedge into the market as opposed to police work or other use cases? Yeah,
I think that really goes to what is in the core DNA of our company. So most of our company comes from planning, mobility, parking, and it's also what we built the product to. Like we yes, we're a mission-driven company, but when we actually think about product roadmaps, our North Star customer or user is a transportation planner, because at the end of the day, they're going to be the ones that are a champion in a city and can deploy us on, at 21,000 intersections in New York City. I would much prefer to go that route, even if it's a longer process, than have to call every building owner in New York City. So that's just the bet that we're taking as a company. But yeah, we think mobility is key, and obviously the time is now, since not so much in New York, but obviously like scooter chaos in virtually every other city in the US, and also the fact that autonomous companies have raised so much money and are deploying infrastructure in cities now.
Questions?
Thank you very much. A really interesting company. So my question is, do you do any work with Vision Zero to reduce accidents between pedestrians, bikes, and cars, and maintain any statistics on how good Vision Zero can be? Do you, maybe it's a prospecting tool for you, a partner?
Yeah, that is actually our core use case. So the example I showed with the crosswalk was entirely focused on pedestrian safety. Vision Zero is our main hook-in with municipalities, absolutely. And if you're not familiar with Vision Zero, it is the goal-setting system to achieve zero traffic deaths in streets. Every city has their own goal, but in New York City, which you think is very pedestrian-friendly, traffic deaths are the #1 killer of children and second second worst killer of seniors. So it's still, even in a city like New York that feels built for pedestrians, it's still an urgent crisis.
How are private companies using the data?
So right now our first API users are actually mostly systems integrators and other vendors to the cities that we work in. That's shifting. We're working more with mobility companies, nothing I can really talk about right now, but because we can detect what is in the street, where it is, how long it's there, utilization. This data has become very interesting to a number of parties.
Hi, my name is Ravi Rao. Thank you very much. Very interesting presentation. Just want to have a couple of questions for you. One is, are you aware of the work being done at Argonne National Labs with Array of Things technology? And if so, what is the difference between your work and what they're doing? Question one. Question two, what is Robert Woods Johnson's interest in your work?
Yeah,
thank you.
Both awesome questions. I didn't plant you, but it feels like I did. So Array of Things, awesome project. Charlie Catlett, who who conceived of the project and kind of helped invent the internet, was an early mentor to us. We actually have a very similar architecture in terms of privacy to their computer vision element. Array of Things is what it sounds like. It's an IoT array with lots of different sensors. They started deploying mostly in Chicago. I would say, quite frankly, the core difference, are two things. One, we're completely focused on computer vision right now. They have a bunch of other sensors. And two, they're an academic project and we are not. So they are under a lot more public scrutiny in terms of their entire R&D process. Anytime they want to change anything, it basically has to, get put through a hackathon and published on 3 blogs and in a newspaper, and they have a lot of review. And we don't have that. We think our privacy approach is actually a competitive advantage. And so, the onus is on us to put it out there. We're not quite under the public scrutiny that a project like that is. And also we are incentivized to build our sensors at scale, whereas their projects, the actual BOM cost, the bill of materials on their device is very high. And so at the fastest, they can't deploy that quickly. To your second question, Robert Wood Johnson Foundation is interested in bike ped safety because in a lot of cities it actually has a lot to do with health equity. So your transportation your transportation choices are the strongest determinant of your health, more than your education, income, background, race. And so they want to understand how to make better transportation systems for cities as part of a public health measure. So that's how we've worked with them in Jacksonville, actually.
Last quick one right here. Hi, Tara.
Hi.
I'm guilty of being on the board of one of the scooter companies from UrbanX. Do you look at the scooters differently when you're tracking on pedestrians where for cities like New York where you can ride a scooter on the sidewalk?
Is your question, do we differentiate them by brand?
No. They're moving faster than the pedestrians on the same pathway. So are they different colors in your?
Oh yeah, so we detect them separately. Definitely one of the challenges with our computer vision approach is how we want to track people with or separately from the devices that they're with. So a person on a scooter, we might want to read differently as a person walking alongside a scooter. Or if a person is parking their bike, do we want to get as specific as separating them, from the bicycle versus defining them as a cyclist on the bicycle? So those are active areas of research for us. Thank you. Thanks so much.
Thank you so much.